Okay, today we are having our 11th lecture on dynamic routing. Yeah, last class we were discussing about the static routing and how routing works and what are the major benefits for the static routings. So second type of routing is dynamic routing, or you can say there are two types of protocol running for the routing. First is static routing protocol, and the second one is dynamic routing protocol. So before moving for the uh, brief discussion about dynamic routing, let's do a little recap about why routing is used and why do we need a routing protocol or a routing mechanism. Either it's static or even it's dynamic. But what is the need of that? Basically, in every network or every communication, we need to transform information, or you can say we want to exchange our knowledge from one point to other point. Same, we want the routers to transform their information from one part to other part, so our traffic can be flown from entire from one point to other point, or you can say the in entire network. So you can say sharing of a knowledge is used for is used as a routing, and of course there's a protocol for this mechanism. It could be static. It's mean we can define our routes, which traffic should go to point A, B, C, and which traffic should not go to point C, D, E. Or this can be done dynamically or automatically by using a protocol. You must have heard about some protocol names like IGRP, EGRP, PGP, RIP, or something like that. So basically, today we will be focusing on these dynamic protocols. Let's first discuss about what is the purpose of dynamic when we have already learned about static routes. Why do we need any protocol which is doing routing dynamically? So the role of network administrator is little minimized. So like let me show you some little points. Like when you have a very large network, you don't want to configure every route manually, or you cannot reach to every router and configure it each and every command and how traffic will go from this router. So you need some protocol, or you can say when you have a large network and the discovery of routes are so much difficult, so definitely you need some protocols to work on. And when you have multiple paths available, you want any protocol to find the best path for you. For example, if I say I want to go from New York to, for example, Australia, so what are the paths available to me? If I'm using over the Pacific, or I can go over Africa and then go to Australia. So it depends which path is best for me, according to the time, according to the cost, according to the uh, traffic over there, and according to the availability, of course. So these are few things which normally dependent upon the choosing of dynamic and static routing protocols. So here my question is that again, which one is better? Which one do you prefer if you were a network administrator and or you are the owner of the network? So anyone can share his input. Yes, who is going to share which one is the best, the dynamic or the static protocol?
I think for the large network,
Dynamic,
the dynamic
dynamic
protocol is a
protocol.
mandatory. And for a small network within office, sometimes if you need only one static route, we can use the static routing.
And Jamal, you also go with the dynamic. And what about the other Fahad Uwais and Idris and Siraj? What do you think? Okay, fine. Actually, you are quite right. But actually, it depends upon our requirement. Mostly, we deal with both of them. Like in the last session, we already had discussion about that, like static routes. Where we use static routes? When you have a stub network, when you want specific route to be followed, then you put a static route. Or maybe you are having a very small network, you don't need to run a hi-fi protocol, or maybe your routers are not that much capable that can handle high utilization or high CPU usage, so you go for the static routes. But definitely when you or stick with some specific route, you must go for the static routes. But normally in today's world, every network is being used by both of the protocols, either it's dynamic or the static. So this was a little introduction. And networks are being deployed and used since 1950s 60s, even it started massively in 70s. But initially the network was very small, or you can say it's not for the whole world or for a different country, it's for the local. So they used static routing or something. But in the 80s, when now network started growing and the evaluation of internet was there, so the use of dynamic routing started. So these are little routing protocols mentioned in the slide. Definitely will be looking each and every protocol one by one. But there are two types of protocols, or you can say there are two types of dynamic protocols right now we are following. One is interior gateway protocol and second is exterior. Just to make it very simple, interior means inside network, which is being used in your network, and exterior means the routing protocol which we use for the outside world. Like my company is sharing data with my customer or my uplink provider. So normally use, or you can say the routing protocol for internet is BGP or exterior gateway protocol. So we will be having a discussion on each of them. But what are the roles of dynamic protocol? That is very important. Why do we use it? Like in the last class we discussed about why do we use static route and when do we use static routing. So here we are discussing why do we use dynamic routing, or do we really need to run dynamic routing on every network? As I discussed earlier, as that it depends upon the size of network first of all. And because when you are running a dynamic protocol, it consumes your CPU of a router, and your router needs to be have some proper licensing from your desired vendor, whatever your vendor is, Cisco, Huawei, Juniper. Or and also you have having a good bandwidth available, because when you have a static route, only traffic flowing on the link is your data. But when you are having a dynamic routing running on your network, um, there are some other traffic apart from data, like uh, the negotiation traffic, and then protocol traffic. I know this is very small in value, but definitely you need to be considered that amount of volume as well. Even sometimes your data has low priority than these, because these are data is like signaling. Because if signaling fails, your data all will fail. So definitely you give priority for these negotiation data. For example, if hello timer for any protocol is missing or it's being choked, then definitely protocol will not be up and your traffic will not flow. So definitely, so you will give priority to the signaling traffic. So these are some little points to be highlighted for dynamic protocols. And when you are having a large network, very large network, or you can say, or you are a service provider, maybe you are having a 5 or 6 router, but you are connected with 100 of customers. So your customer is also a part of your network. They are connected with you. You want the specific route to be transferred to them and specific route to be received from them. You need some control, or so you need mm, routing, dynamic routing plus some static routing to run on your network. So these are some advantages and disadvantages. As I mentioned earlier about some advantages of dynamic, and also the disadvantages. Like what are the benefits of static is basically a disadvantages of dynamic. For example, if I take example for the utilization of CPU, RAM, and memory, definitely in static it's an advantage, but for the dynamic protocol it's become a disadvantages. But the static routes are a little more secure. How does it is secure? It's mean if I have put one route from to be followed from one point to other point, it's remain till I change it. But in dynamic protocol, it depends upon many factors. Like it could be cost, it could be some network change, or it could be from your peer end. For example, maybe I have three links with my customer, and two links are down. Then your whole traffic will be flowing from some very small or slow path. Like for example, I have two fiber with my customer and one radio link which is like of 50 MB or something, and my fiber is working on 1G and 100G links. But definitely if these two links are choke, or maybe if there is a configuration mismatch, your peer end or your client and he has made some mistake, so despite you are having these two links up, but your traffic will start flowing from your third link, which is supposed to be used only in the case when your network is down. So there are some security and some less adaptability issue in dynamic protocol, but definitely we are using both of them. And just a random guess, if I say 80% of time we are dealing with dynamic and 20% of the time we are dealing with static, because static routing is only being done for specific routes, or you can say specific links. But dynamic routing is used everywhere inside your network, outside your network, or within your different part of your network. So we will be learning dynamic routing right now. Okay, so before going to each of dynamic routing protocols, first of all, let's discuss what basically process or the operation of dynamic routing is. Okay, if I compare it with static routing, for example, if you say what is the process or what are the operation for static routing, it's very simple. You just write, or you can just define router like these are my destination address and I want to go to this address. Then I define what path I should take. For example, if I say I'm standing in an airport and I want to go to uh, you can say the runway. So I the airport staff can tell me that you should use this path. This is very simple. But on the other hand, if you want to configure dynamic routing protocol, or you want to define a dynamic routing to a router, you need to do some steps before running that protocol, and some step during the that operation. For example, when there are two routers, they want to run a protocol. Definitely when any protocol is going to be run, there's some negotiation messages are being sent from both sides. If they agree on the both agree on that negotiation points, then the peering, or the you can say the connection become up, and they started sharing their information to each another. So after the interfaces are up and they are negotiating with the parameters ABCD, and then their protocol becomes up, and then they exchange their routing information to each other. For example, the router A say that I have this information available to me, and I'm sending to you, and the same process will be followed by the router B. He said I have ABCD that information, and I want to share with you. And also these router will share their topology like that. They said I have connected with four LAN, or you can say four subnet, and I know my one loopback interface which is logically connected to me, and I want to share this information as well, and the same process will be followed by the router B. So these are few steps that has to be followed before dynamic routing protocols to be start working. Okay, so this is the process which I just defined you briefly in some word. It has been shown in these upcoming three slides. For example, we have one protocol, a uh, routing information protocol, which has to be, which was supposed to use in older times we will be learning what is this, but they just define what are the 3 or 4 steps before they started running the protocol and started sharing the traffic. So first of all, for example, there are 3 routers ABC. You can see the router A and router C. This router A and the router C, they are, yes, this is router A and this is router C. They are connected with a LAN, and remaining, like router B is connected on a WAN interface with router A and also connected with the router C. So what are the steps? So they started routing protocol. First of all, the router 1, which is connected with a LAN interface and having an IP 10.1.0.0. All the theory is also written on the slide as well, but let me define you in a little easier way, and you can read these values or this theory also later, but I'm defining in an easy way. Like in first step, every router will share its available interface. The available interface means the interface which is connected with having a certain IP. For example, in the case router A, router is connected with a LAN with having IP 10.1.0.0, and router 2 doesn't have any LAN interface, but it has two WAN interfaces. One with 10.2.0.0 is subnet, and the other one with be 10.3.0.0. And also the interfaces number are mentioned, like the the WAN link between router B and C is on the serial 00/1, while the WAN link between the router B and A is /0/0/0 means serial 0/0/0. Okay, so every router is adds information about the interface which are available with them. Like in the layer 2, they have a VLAN map, or you can say MAC table. We in routing world, they build the routing table, or you can say the routing information base, which is normally used as RIB. So in starting, they just mention like I know this network which is connected with my this interface. Definitely, if it is connected, so hop means 0. It is directly connected. You don't need to write an hop or something like that. But when you go further in the second step, when you are going for network discovery, because as I mentioned in the previous slide as well, that in the initial states, the router share his knowledge and also share the knowledge of which they have already learned from uh, the previous experience. Maybe it's from the static routing, or maybe it's from somebody else router. So now in the second step, the router updates about the network which are known to them. For example, router 1 is also updating in the routing table that I know 10.3.0.0, although which is not directly connected to them, but it know it's coming from router 2. So he adds this IP's input into the his routing table, but he mentioned one hop. It's not available to me directly, but it is available to me on the one hop available. Same with the router 2, it also adds all the information which is available to router 2, but it's on router hop 1 on the right side and hop 1 on the left side. So it store all the data on his routing table with the metric 1, or you can say hop. In the RIP, the decision is based on the hop. uh, Basically, the routing table or dynamic routing table depends upon metric. A metric could be a single thing, or it could be a bunch of different things. For example, in the case of RIP, where the RIP works on the hop, like uh, from router 1 to router 3. If, for example, if I had one more path available here, so he will always use the hop count, because if I want to send traffic from R1 to R3, if I use this path, I need to pass with two routers. But if I pass traffic from router 1 to router 3, then there's only one hop. So the RIP only works on the hop mechanism. So when you come with a different protocols like OSPF, which has a metric but little complex, it works on reliability, cost, and everything. So it takes decision on that metric value, which metric is all already you can say a bunch of different values. We'll discuss that thing too. Okay, the same process which R1 has already followed, which will be followed by R2. It's also add all the information which is available to R2 with different sources. Same process will be done by the R3. He adds all the information which is available to them. Either it's directly connected with the hop 0 count, or it is connected with some other router and he know that information from router 2 or router 1. So he adds that information. So in that case, your network becomes uh, easily available to each and everyone, because everyone knows the route which are available to them, and also available to the peer end. Okay, in the last step, then they started exchanging their routes. For example, in the case, in this case, or you can say in the third step, the R3 router doesn't know the LAN IP of 10.1.0.0, which is connected with the R1, but he uh, he already got this information from R2. On R2 has got that information from R1, so he write 10.1.0.0 is getting from this interface, but the hop is true. It's mean it's not the information which is connected with my peer. It is coming to some other router, but my peer is sending to me. For example, if I say I got one information which is available to me. I got one information from my friend, but this is the information which my friend told me. Definitely, that information is not available to my friend, but my friend's friend has already told him. So in this step, all the exchange of routes are uh, is made. Now, anytime if some PC comes to the R3 and he wants to go to 10.1.0, so definitely he must have already had this knowledge. Like this is available to R2, but it's on two hops. The same is a process with the R2. Now R2 is exchanging routes. This is and now the process for the R1. Now our R3 is exchanging the routes, and now he's updating all the entries to his table. Okay, when all the routes are exchanged, when the protocol was up by making negotiation agreed on the both end, then we said this is the convergence. For example, if I say open one router and then the second open the second router, they are both configured with the RIP protocols. So initially, what they will do the first of all, the interface become up, the physical interface will become up, and the logical interface will become up when they start negotiating on the protocol values, like what should be the timer, what should be the hello field, or what should be keep alive timer. Keep alive timer, it's mean like for every like 10 seconds the router one will send a ping, like, oh hello, are you there, are you there. If he replied, it's okay. If it doesn't reply for three times, then he considered is to be dead. Then they drop the peering, or you can say the communication of routing has been dropped. But when the peer is up, they started sharing the knowledge. They started topology transfer. Then all this process has completed. Then the time which consumed is called as convergence time. So initially we had very long time for convergence, but now protocols are so fast. Then whenever the interface become, they started sharing the data and the knowledge of routing information or change in topology within no time. Like EIGP is so fast. Like if interface is flapping uh, with any reason, maybe due to fiber cut or a microwave link down, but they share knowledge within no time. So it's very fast, because as soon as maybe you have observed one thing, when there is a layer 3 links, if it is break and then it's become up, the ping started within no time. But on the layer 2 hop, when you started giving uh, port up, then it takes time to become transformation of traffic. Okay, before going into the classification of these routers or routing protocols, let me ask some questions from you, or do you have any question you can ask me? Okay, my question is that like we have heard about different protocols. So any router can run each protocol, or is it defined like this router needs to be run this protocols, and like there are some protocol names written on this slide as well. You also knew the names of the protocol like BGP, OSPF, EIGRP, RIP, IRG, IGRP, RIP1, RIP2. These already you heard the names. So let me tell you what is your say on it. Yes, please.